Hello, in front of us we have May 2023 Paper 1 Question 10 Timezone 2. You may pause the video and then try it yourself before we discuss it together. Okay, we have a basketball above the ground in meters, and then we already have the function, this one. First question, find how long it takes for the basketball to reach the maximum height. We have two ways at least. The first way, you can use calculus, find the first derivative, find the maximum. The first derivative equals to 0. Or you can use algebraic, you can use factorization, find the zeros. Or I'll recommend you use your calculator, because your calculator is your friend in this case, yeah. Okay, input it in the calculator. Y equals to negative 4.75. Our calculator do not recognize t, so just x square plus 8.75x plus 1.5, and then the window. The x is the time. Let's say if we throw a ball, maximum time in the air is 5, and then y max is the height. Let's say maximum height, let's say it's 20. That's quite high. Then let's graph it. Okay, that's good enough. Okay, our window is too big. Let's make it 10 maximum. So I would like to see the clear picture of the graph. Okay, there you go. So find how long it takes for the basketball to reach the maximum. So it means here, second, trace the maximum, enter. We have left bound. Where's the left bound? Oops, left bound. Okay, enter. Right bound should be on the right of the maximum. Enter once again. So we have maximum 0.921052. But to do that, we have to sketch it. You don't need to draw it clearly, just sketch it. So question A, so we have something like this. This is the x, this is the y, and then your graph look like this. And then what's the maximum? The maximum, different calculator. Sorry, I have two calculator here. 0.921052, 0.921052, comma, different calculator, 5.529, 5.529, blah blah blah. Okay, meaning when the time is 0.921 seconds, the height reaches the maximum, which is 5.529 blah 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 meter. What's the question? The question is find the how long it takes for the basketball to reach maximum. So question A, time is equals with 0.921 second. Okay, no need to find to give the height, yeah, because that's not in the question. Question B, assuming that no player catches the ball, find how long it would take for the basketball to hit the ground. The hit the ground means here. Oops, different calculator again. I'll just close that calculator later, yeah. Which is here. Okay, when the the y, the height is equals to 0. So the y equals to 0, we will make the second graph, y equals to 0, and then graph it. We should have two lines. We need to find the intersection here. Second trace the intersection. It looks like 2, but let's just be sure. Enter. Yeah, x is 2, y is 0. So you can just put it here. This one is 2, 0. If you already put this in the first graph, you don't need to draw it again. So the assessor should know that it's coming from this one. Find how long it would take for the basketball to hit the ground. It takes 2 seconds. That's it. Okay, you already give our method in the A, yeah? It should be clear. Question C. What's question C? Another player catches the basketball when the height is 1.2. Find the value of t when this player catches the basketball. Okay. Cool. It means the I'll just close this calculator. Sorry, that's annoying. So we have to make another one, which is in this case 1.2. 1.2. Let's graph it. Okay, so the ball goes here, and then this one 1.2 is here. Second trace 1.2, the intersection. The first curve, the blue one, enter. Second curve, the red one, enter. Guess, nope. So we have x is 1.875 blah blah blah. So let's make a line here. Okay. Okay, that's good enough. You know what I'm trying to do. What's the point? 1.8757. 1.8757 comma 1.2. So it means t is equals to 1.8757 blah blah blah, or t is approximately 1.88 second. Okay, you may sketch new one, but as long as it's clear here, this is our steps, it's okay. Question D. Find two limitations using ht to model the height of the basketball. This one, as long as your answer, this is open-ended question, yeah. As long as your answer makes sense, it's correct. I already screenshot the answer, possible answer that are allowed from the mark scheme. You can use the model, ignore the air resistance, it treats ball as a point, it's assumed the gravity is constant, it's follow the trajectory even after the hitting the ground, and then there's no bouncing back. Okay, you can use that. The one that you cannot use is the assumptions, the model as never accurate, or it's just a model, blah blah blah. Okay, this is the answer that you are expected to give. Okay. Okay, that's it for this question. I hope that helps. Thank you.